All right, let's get started with welcome to another episode of Web Dev. Let's see. All right, we are in the second half of our semester. We're working on the server side, the back end of our client server application. Right, the first half of the semester we did the front end with React.js, CSS, HTML, TypeScript, and in the last couple of lectures we've discussed how to build an HTTP server, right, where we can delegate a lot of the work that we've been doing in the client, like maintaining state, right, and manipulating data. We've been moving all that to the server. We moved several JSON files, our quote unquote database. And and we focus mostly on the integration of these two sides of the application. But it still remains that the data that we are creating is really not persisting, right? I mean, certainly persists better than what we had in the client because we have variables declared on the server and they live as long as the server is running. But in reality, we're not persisting permanently. For that, we'll need an actual database, right? So the next couple of lectures are going to focus on that, right? How do we create a database and then integrate it with the Node.js server so that our modifications are permanent, right? It's for long-term storage. And for that, we're going to be talking about MongoDB as our database and then how to integrate it, right, with Node.js using the Mongoose library. Right? So that's going to be the focus of the next couple of lectures. All right. All right. So let's talk about MongoDB. So MongoDB is a database, right, of many different types of databases that are available, but it's a non-relational database, right, that is going to allow us to extend the storage solution, right, the permanent storage solution of our web application. Right now, right, our server, right, using Node and Express, right, it's storing all its data in local server variables, right, and again, it's much better than what we had when we install, keeping the data in the client, right? In the client, those variables would not survive a refresh, right? When you refresh the browser, all that data that we would manipulate, would just go away and reset to its initial state. Now they're in the server, they have certainly a longer lifespan. Right? Certainly we can survive the refresh on the client because the client can go back to the server and the server can give it the current value, the current state of the application so that the client can reconstitute its state. But if you restart the server, all those state variables go away. So for a real permanent storage solution, we'll need to add a database, right? And what we're going to do is that today we're going to create a database and integrate with it from our Node.js server using a library called Mongoose. So we're going to be using MongoDB. It's one of several non-relational databases or NoSQL databases. And what that means is that it doesn't use the classical SQL language, right, to interact with the database, right? It doesn't use the very familiar tables and foreign keys and primary keys to organize its data, right? Instead, it uses what it's called collections, right? And collections are the equivalent of tables. And instead of storing records in rows instead of tables, we are going to be using, we call them instead, documents, or usually formatted as JSON objects, that each one of these documents or instances are stored in collections, right? So there's going to be a users collection, there's going to be a courses collection, modules collections, and so on, right? And each one's going to be a collection of instances of users, of courses, of modules, and so on. Another thing that's going to be somewhat new is that typically we think of these relational databases, the very first thing that you do is create a schema, right? Or you configure what the table looks like. What are the fields, the data types? In non-relational databases, we don't do that on the database itself. Typically, it's done at the application level, right? It is the application who's going to be responsible for maintaining the schema, declaring what the structure of the data looks like, and it's going to be responsible for validating and making sure that the data that we insert or update is matches, right? It's going to validate against the schema that is, again, it's going to be responsibility of the application as opposed to as the database server, right? And and we're going to introduce the notion of models in non-relational databases that are going to allow us to interact, right, with the actual collections, right? They provide, all the low-level API that we need to be able to talk to the database, right? So the Mongoose models provide things such as, finder methods to retrieve data, create methods to be able to insert data, update methods, delete methods, right? All the low-level API that allows you to, send commands to the database to actually CRUD, create, read, update, and delete the records in the collection. Above that, on top of that, we're still going to have the DAOs and the routes that we discussed in the prior lectures, right? They're still going to be responsible for, routes for integrating with the web application, exposing RESTful web APIs so that the client user interface can then, integrate with the server application. And the same DAO is going to be, we're going to use this, same DAOs that we implemented in the prior lectures, right, that are responsible for the actual manipulation of the data. We'll have to make a few changes here since the current implementation of the DAO is manipulating a data structure that is local, to the server, right? It's manipulating, arrays and objects that are maintained in the memory of the server, right? It's our, quote unquote database that contains an object, a map of courses, of users and whatnot, right? And they're all loaded into the memory of the server. This time around, that data is not going to live on the server. Instead, it's data that is going to live in a separate process, right? That is running outside of the server, perhaps, halfway across the world. So these DAO, right, are going to be, we have to rewrite them so that it is going to, instead of using the local arrays and manipulating the local arrays, are going to be using the model, right? The API that the model provides to talk to the database to, implement all those updates, inserts, deletes, right, retrieval and whatnot, right? Also because it's running in a separate process, again, perhaps halfway across the world, this communication is now going to be asynchronous, right? So just like we wrote these clients to asynchronously talk to their server, right? We wrote them in such a way that uses the keywords, async and await. So similarly, we're going to have to rewrite our server that talks to the database so that it uses the same strategy, right, of asynchronous communication using the same keywords such as, async and await. We are working with a non-relational database, MongoDB, of which is one of several types of databases, right, that fall under the umbrella of NoSQL or non-relational database. And again, what we mean by that of non-relational is that it's not what we classically have been using for decades, right, that has been dominating the database industry for quite a while, that whenever we think about storing data long term, we think of relational databases where we think of tables, right? And each table having rows, and each row, and then rows have fields. And typically the data stored in these relational databases is flat records, right? Where you have, a vector of fields that are mostly just primary, primitive data types, integers and booleans and strings and whatnot, dates, and that don't generally allow you to work with complex data types that, if you need to go beyond, primitive a collection of primitive data types, you need to combine multiple records from in multiple tables that combine by using relationships between the tables, hence the name relational databases. And those relationships are typically, implemented using foreign keys and primary keys, where, a field in one record references another field in another record. And by combining these, you can create, hierarchical data structures, right, and complex data structures. So now the non-relational databases, it's not going to use those concepts of breaking up content in multiple tables or collections. Instead, we can store complex objects, instance objects, typically formatted as JSON objects, right, as records. Instead of a record, right, you have an object, a JSON object that gets stored, into these databases, and these objects can be arbitrarily complex, right? They can be have, just properties that a property can be either a primitive data type, or a property it can itself be some complex data type that can be another array or another object that contains other arrays that contains other objects. So it could be arbitrarily complex, minimizing the need for foreign keys and primary keys, because I mean that was the original intent of needing these relationships, right? Because that was the only way that you can model, complex data structures, right? Is by combining, these tables that reference one another. So, certainly you can accomplish what relational databases do in non-relational databases, but, because you can store complex data types, complex object instances, it opens up a lot of more options, right, of how to model the data that you want to store long term. So we're going to be using MongoDB. If you haven't already installed it, you can head over to mongodb.com and you can download the local server, a server instance that we are going to run locally on our machines, right? And there's a free version, a community version, right, that you can download, install, unzip it in your local file system. And once you store it, typically in, if you're on a Mac, then usually this, when you unzip it, typically it would go under user local. And under there, you'll get a, a folder that looks something like this, MongoDB, macOS, so and so, depending on your CPU. And in there, there's a bin directory that, the most convenient way to use MongoDB is to add this bin directory, right, this entire path to your local path environment variables, right? In the bin directory, there's several executables, MongoDB executables that allow you to start the server, do some system administration and so on, and also to start the shell so you can talk to the server. And so it's most convenient, if that bin directory, this path, is in the path, so in your environment variable, so you can run it from anywhere. On Windows, similarly, you can unzip the install for the MongoDB in your program files, and again, in there there'll be a bin directory that you should add to your local path environment variable for Windows. Once you have that, you can start your server, but the server is going to look for a specific folder that is either in a very specific place, or you can decide where to put it in your file system. As long as you know where you put it, you're good, right? One common place to put it is in your home directory. So you can do, cd tilde, right? And that puts you in your home directory. And in there, for instance, you can create a folder. Typically, you can call it something like data, or maybe, data/db or something. As long as you know what the folder you create. Once you do that, right, you can start the server by running Mongodb. Now you can just run Mongodb if you added the path to your, right, the bin directory to your path. Or if you didn't do this, then you would have to say, user local something 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 bin, and then Mongodb. Now, if you just run it like that, it's going to look for this folder, this data folder, in its standard place, right? That which is at the root of the operating system, the file system. But oftentimes, folks don't have permission to create folders at the top level root directory. So, right, if you're not a system administrator or you don't have enough permissions, then you can create it in your home directory. And in that case, you'll need to provide you need to tell it where to find it. If it's not at the root in the default place, you'll need to specify it by using the --db path option, right? And then you can tell it, okay, well, it's here, right? And you can give it the folder path of where to find the data folder. Also, if you are on Linux or Mac OS, it could be that, to start the Mongo daemon, the Mongo server, you'll need to use the sudo command, right, in front of it that gives you the super user privileges, right, that would allow you to run this executable. Once it starts running, you'll see, a long log, telling you that it was successful or not, right? And that it's listening at a particular port. The common port is 27017. That's the standard MongoDB server port that listens to incoming requests. Let me demo this. So here I'm at my terminal, and we can start the Mongo database, right, by going to our user local. Now I am in my home directory, and I do have a data folder, right, in there. And so I'm going to use that as the option, right, to tell it to where to store all the database information, right? So let's start user local, and then we have I got a couple of versions here, arc there, and then in there we have bin, and we have MongoDB, and we can provide the location of the database as db path, and I'll give it the location of data. So it's going to start up, right, and it'll say that it's listening at our local machine, right? This is local host, and it's listening at port 27017. That's the default port that Mongo listens to. So let's talk about Compass. So MongoDB Compass is a user interface that is going to allow us to interact with the database, right? You can create a new connection, right, and tell it where the database server is running, right? And for instance, you can tell it, MongoDB, it's running at localhost, or you can use 127.0.0.1, colon, and then the port number that it's listening at. Now, this is connecting locally to your machine, but later on, we're going to be using an online service where MongoDB is going to be running remotely, right, on the cloud. It's a cloud service. And it's going to tell us what the IP address is and the port number and whatnot. And you can copy that URL and create a connection that connects to that remote database as well, right? So typically you'll use Compass, connected to your local database, and another connection connected to the remote database, right? And you'll be responsible for maintaining, both connections. You do all your local development, on your local desktop or laptop. And once you are, happy with your work, right, you can port all your data up to the remote server and keep working remotely. Once you have created the connection, you can create a database, right? You can say, create a database. You can give it a name, right? And then you can tell it, the initial collection name. Collection would be the equivalent of a table, and that in that table we can then upload data, right? Or you can insert new data. which you can either insert individual records, you can say, you can add an entire collection, you can import a JSON file that contains the array of users, an array of courses, modules, and whatnot, right? And it inserts records for each one of those documents. Once you have uploaded the data, there's an option also within the Compass user interface to interact with the database manually. You can interact with it graphically, right, through this user interface, or down below here where it says Mongo SH. That's the Mongo shell, which allows you to interact with it, like in the command line, right? So for instance, everything you can do graphically, you can also do it manually. You can select the database using commands such as use, right, and then canvas. And it is very similar to what you would do in other databases, right? Or like SQL Server, MySQL, right? These commands are, very, very familiar, if you use other databases. What's different quite a bit is the syntax that you use to interact with the tables or collections, right? And with individual records. The way you interact in a SQL or a relational database, you use the SQL language, right? That allows you to use commands such as select star from, and then the name of the table, or insert into, or delete from, or update, and so on. And so, whereas the non-relational databases have their particular language that is specific to each vendor. For MongoDB, right, the syntax for interacting with the database is that all the commands start with a db dot, right, db dot. And then it allows you to select which collection are you interacting with, right? Like which table. Here are, instead of tables, we call them collections. So db dot courses means that we are interacting with that specific collection of courses, right? So db courses identifies the collection that you are interacting with, and then dot, right? We use the dot notation to navigate some data structure, some object, and then the last one here is the actual command that, right, talks to the database and does something. For instance, there is a command to retrieve the records from the database. Does dot find. Dot find is the equivalent of the select statement, right, in a relational database. And the parentheses in here allow you to configure the what to find. If you don't provide any arguments to the find, this is equivalent to doing select star, right? Select everything, select star from courses. So this is the equivalent of, select star from courses, right? And what you would expect is all the records in courses. Here you would get all the documents in the courses collection. So let's take a look at some of the commands that we can use in the shell, right? At the command line. There's a find, db.courses.find, like the name suggests, right? Allowed you to retrieve data from the collection specified. And it takes as argument an object. This object, right, has name value pairs or properties, properties colon value, that are used for pattern matching. That it's going to pattern match the object that you give it. It's going to try and find, it's going to iterate over all the documents in the courses, trying to find a partial match of the courses that partially match the object that you give it. So for instance, here we're trying to retrieve a document by its primary key. And the primary key can be a string, or like we have chosen, or it could be a native data type called object ID. Object ID is its own internal representation of a unique identifier that we can use, as the default primary key, right? We have chosen to use a simpler data type, just a plain string, and we are responsible for creating those unique identifiers. Otherwise, we can, let the Mongo database create, its own primary keys. You can choose to use either one. We chose to be responsible for creating our own. So once the MongoDB finds a pattern match of that particular object that has that primary key value, it spits out, it renders the actual entire document, right, that matched or partially matched that primary key, that or that field with that value. You can also query it, using other properties which are not primary keys, right, like number here, although number probably is also unique. And then again, that is partially matched against any object that has that property that has that particular value. You can combine multiple properties. You can have a department, a number, term, and you can give it, and you can comma separate all those properties, and all of them will be partially matched against the objects. If it matches more than one object, like for instance, here we have these three documents match the department D134, so it returns all three documents, right? They're unique. They have unique primary keys, right? And they have, unique names, unique numbers, but they all belong to the same department. It returns all instances that match. Let's talk about data modeling. What we mean by data modeling are the choices that we make when we decide how to organize the data. And there are quite several options of how to organize the data that we're going to store in our databases. One of the common ways to organize data is by using what is called the one-to-many relationships. Now, obviously, we can also certainly make choices on organizing a specific collection or one of the collections, and what fields to use, what data types to use for each one of the fields. Those are obviously also part of the modeling task. Here we are concerned with the relationships between multiple collections or multiple tables. So those relationships, one of the ways to implement that relationship is called the one-to-many, where what we mean by that is that one instance or one record in one of the tables or collections is somehow related to multiple, 0 or more records or objects, right, in another collection, right? So one to many, right? And typically the way you capture that in diagrams is, in particular the UML diagrams, right, is to have a line in between the collections or tables, right, or classes, and then providing cardinality numbers on either end of the line, right? So where you have the one side, you put a 1, and then when you have the many side, you put an asterisk. Or if you know how many exactly, then you put those numbers or range, right? But if you don't know how many, and you know that it's at least it's 0 or more, then asterisk captures that idea. An example for our particular use case is that a course can be related to many modules, right? Where the course can have many modules, and so if you navigate to one course, you have modules 1, 2, 3, 2, 3, 4, 3, 4, 5, or right, if you go to a different course, you'll have a completely different set of modules. Now, in for data modeling this, we have a couple of options, right? And depending on what we're trying to do, we would choose one versus another. One option is to have the parent course be aware of the instances of the modules that it contains. Now, this is different than how we typically would implement that in a relational database. In a relational database, typically you implement one-to-many by having the many side, right, the modules, for instance, have a foreign key, right, that references the parent, right? So for instance, here the modules, each module would have a field, right, that captures the value of the course that it belongs to. So that each module would have the ID of the course that it belongs to. So it is the many side that has a reference back to the one side, right? The children have references to their parent. The parent has no notion, right? No reference back to the children, right? So the course knows nothing about the children. It is the children who know about the parent, right? It is an inverse relationship. But because we have now we're using non-relational databases, we're not stuck with this only option, okay? Instead, there are a couple of other options that we could consider. One of the options is to have the courses, the parent side, on the one side, right, have all the references to the modules that are its children. It is the parent who has references, all the IDs of the modules that make up that one course. Instead, the modules would not have any reference back to its parent. The modules would be unaware of its parent. The other option, also available to us in a non-relational database, is that we might not even have a separate collection of modules. Instead, we can embed each of the instances, all the modules, right, in an array, right, inside of the courses, right? We can totally, capture all the modules here in the courses, right? Completely obviating the need for a separate table or a separate collection. Now, whether we choose one or another depends on what is that we're trying to achieve. Now, in this case, the existence of a module, right, has no meaning outside of its course, then this implementation would be totally fine, right? You get the courses, and then each course has the modules, the array of modules in there. There's no need for modules to have a reference back or an array, right? To even have an additional table, right? Because you would never access a module outside of the context of a course. You would never ask for a list of all the modules, outside of a particular course, right? It just makes no sense. So this would be a completely great option in this case. Now, let's consider another case, right, where, for instance, we might have a metadata. And in the metadata, right, typically the way that is implemented is by having an intermediate table or intermediate collection that has foreign keys, right, or references to the records that are associated. So for instance, here you might have a reference to the user instance, right, and then associated to the course instance, saying that this user is enrolled in that course. Now we could consider the other options that SQL might allow us to do. For instance, we might, instead of having an enrollments table, we could say, well, the user could have an array of users of courses so that it points to the courses. And then instead, the course can have an array of users that points to the users that are enrolled in that course. So you would not have the need of an enrollments. And that's totally fine. That's totally doable. The challenges, though, is that, right, if a user unenrolls from a course, that means that we would need to remove that course from the array of users. But then we would also have to make sure to also update the related course, right, to remove the user, right, from the students enrolled in that course. All right. So we have to remove the course from the user and the user from the course. Otherwise, you could run into a case where you have an inconsistency, right? That maybe we only removed it from the users or we only removed it from the course. So from the user's point of view, right, you are unenrolled from the course, but from the course's point of view, you are enrolled, right? So we want to avoid those inconsistencies. So perhaps we might avoid implementing that, right, of having separate arrays on both sides. The other implementation might be that the user maintains an array of the course instances, but that problem brings up an entirely different problem, is that that same course might be enrolled, another student might be enrolled in the same course. So you're not going to, copy the entire course object in the array of courses in the user. You're going to have to copy that for each one of the users that are enrolled in that course, right? Or vice versa. Courses, you can have an array of users and then the instances of the user. But then that same user is going to be copied in multiple courses, all the courses that it's enrolled in. So you're going to have, now you have the case where you might have, a lot of redundancy, right, of the data being duplicated in multiple places, right? Again, opening up us for the risk of inconsistency, right? And so again, so we might in the end choose our classical implementation where the enrollment is captured only once, right? That a specific user is enrolled in that specific course, right? Without using our new capabilities of embedding the object inside. So here the enrollments, that might be a better option, whereas in this one we might have a chance to be much more compact and not even have an array, a separate module collection or table. So here's Compass, and we are going to either add a new connection that connects to MongoDB. That's the standard location and port, and we can give our connection a name, right? This could be fall 5 Wednesday. It's a save connection, and there it is. And then that connection, we can then create a database, right? So in that connection, we can say create database for this specific course, right? And this could be something like, since we are building the Canvas application, right? And we can give it maybe the term, and give it maybe the section that we're in. And we can start off with an initial collection name. For instance, let's start off with the users, right? And then we'll create other collections to capture courses, modules, assignments, quizzes, and whatnot. Okay, so create a database. Well, there we have it. So we have the users. Now we can insert individual documents, right? Or we can import JSON files. So let's import the JSON files that we've been using throughout the semester. Right? So let's take a look at that, and let's go into our folder to see if we can find some of the JSON files. There we go. So we have a user JSON. You can preview it for a second. That looks right. So let's select that, and let's import that. And there it is. So we have 9 records that were imported. And we can repeat the same process to import all the other collections, right? So we can add maybe the courses, create the collection, and we can import the JSON file. So let's see, we have courses. There they are. Let's add a few other things here. Another collection, modules. And let's import the modules. There we go. Another collection, enrollments, import. There we are. Okay. All right. So we have imported all our data into our permanent storage solution of MongoDB, our non-relational database. We are now going to go to the, to our source code, right? And we are going to refactor it so that it uses this database instead of using the local files. Okay. All right. So let's talk about Mongoose. So Mongoose is a library that is going to allow us to integrate the server to our database. And certainly we can interact with the database manually, right, using tools such as Compass. So Compass allows us to talk to the database by inserting, retrieving, doing all the CRUD operations. But we don't want to do that manually. We want to do that programmatically. We want to write a program, a server program that can connect to the database, right, and do all those operations following a certain algorithm, following a particular application that we're going to be building. So we're going to need to install Mongoose, right, and then connect to it from our source code, right. So let's do that. Let's see. Yeah, the server's running. And let's see what branch we're in. So let's create another branch for the assignment 6, right, where we're going to learn about using MongoDB and Mongoose. So we'll do git checkout -b, we'll say A6. Okay. And let's start off let's install the library. So npm install Mongoose. Okay, so installed, and so we can restart the server. All right, so what we're going to do here is that we want to be able to connect to the database, and what we're going to do is that we're going to create an environment variable where we are going to capture the URL of where the database server is running, right? And the name that we're suggesting is we'll call it Mongo connection string. Okay, so let's do that. So Mongo connection string, and yeah, it's MongoDB localhost 27,000. Now the database that we are using is called Canvas. Locally, it's called Canvas, and the term and the section, right? We can save that, and then inside of our index, right, we can import our Mongoose library. So import Mongoose, right, and load up the connection string. So const connection string is going to be, let's see, it's going to be by default is going to be the Mongo connection string environment variable that we just configured here, right? Or if it's not set, then we're just going to default it to something local, right? So I'm going to copy that name like that. Okay. Once we have that, we can connect, using Mongoose, right? We can say mongoose.connect and then the connection string. So it would be Mongoose connect and then the connection string. And hopefully this connects us to that database. This is just like what Compass did. It connected to that particular IP address, that particular port, and it's connected to that specific database, Canvas, and the name. So we're not connected. Now we need to write the code to talk to the server. The way we're going to connect to the server is that we have to define schemas and models. So the schema is going to declare the structure of the data that we are interacting with. And the way we do that is, right, we use the Mongoose library to create our schema. And the schema is just a collection of properties and data types, right, where you declare the names of the fields and then the types of those fields, right? This is very much what you would do in a relational database when you're declaring a table. Give the name to the table, then you provide all the field names of the table, and then you say whether something is an int or varchar or date, integer, and whatnot, right? So this is very similar to that. Now, in a relational database, that job falls to the database itself. The database is the one who's maintaining the schema, the structure of the records that are being inserted or updated. And it's also responsible for validating right? That if you insert data into that table, that it matches the schema, all the constraints, right? That we assign to each one of the fields, right? That something has to be a string or varchar, an integer, a boolean, and whatnot. In a non-relational database, that job is no longer going to be the responsibility of the database itself. Instead, is the responsibility of the application. In our case, our Node.js application using the library Mongoose. So let's create user schema and let's talk about that. So let's create here, under users, a new file schema, and let's import the Mongoose library and use the new schema. And here the AI is already suggesting a few things. Yeah, all good options. And let's see if a couple of things. So username, we have the ID here. Let's say ID is going to be a string. Username, password required, blah, 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 first name. And then we have last name, email, date of birth, created. So date of birth, date. What else do we have here? We have role. So let's do role. Student, what do I have here? Student, faculty, admin, and user. Student, admin, faculty, and user. And default is user. Okay. And what else we have here? Login ID, section, last activity. So login ID, string, section. Now, when you declare the type, you can either use the syntax of using the type, right, like this, or you can use the shorter syntax of just giving the data type like that. That's the short form. Like here, we've used a combination of both, right? Where we have, we have a couple of examples where we're using just the short version, and we're using some long version over here. This is fine. This one is the equivalent of this one. And you would, but I guess the only reason why you would use an object to configure the type is that if you want to configure other things, like for instance here, ID is being configured to be a string, but that's all we're saying, right? That it's just a string. And whereas a username, we're specifying not only is it a string, but it's also required, right? I guess in ID, we would also want this kind of configuration that it is unique and it is required, right? You have to give me a primitive data type, a primary key ID. Username is required, meaning that if you do not provide me a username when you insert this record or this object, right, then the database is going to fail it. Or Mongoose is not going to allow you to insert something that does not have a username and does not have a password or doesn't have a ID, right? Email, no, I'm not going to say it's required. And also here we're saying that the username and the primary key and the email all need to be unique. Whereas the password is required, but it doesn't need to be unique. You could have two people with the same password. The first name and last name, again, we could have used the shorter syntax of just providing the data type string. Same thing with last name. Date of birth, we could have used the shorter syntax of just date, right? Role here, we're saying that it's an enumerate data type, right? That is a string, but it can only possibly have these values. These are the only allowed values for this string, right? And it has a default value of user, right? So all of these could have, default values, right? Anything could have an enum, right? Where are the possible values that you are allowing? So last activity, what else do we have? We have total activity is a string. total activity, also a string. There we go. Once we have the schema, we are going to export the schema. Okay, export default user schema. There we go, like that. Okay, all right. The other thing that we're going to declare here is the model. So the model, right, is going to provide us with the low-level functions that is going to allow us to interact with the database. Something that we got in the schema is that here we are also going to configure the collection. So this is going to be the table or the collection where the data is going to be stored, right? So like in Compass, right? Here's a Compass, and we have all these collections. The user collection, you can make it a little bigger, right? We have the courses collection. We have so this is the collection that we're going to be storing it, right? Okay. Yeah. So we have the schema. Let's now create the model. So the model is going to import the schema, right, from the schema file, import Mongoose, and is going to create a user model like that, right, with the schema. And this user model is what is going to allow us to manipulate the database, to talk to the database. It's going to have functions such as, for instance, you can say user model. It has there's create, which inserts the data. There is find to retrieve data. It has find by ID. If you give it a primary key, it'll fetch the record that has that primary key and so on. It has a whole bunch of delete functions, got update functions. So functions that are going to allow us to implement all the CRUD operations. Okay. Once we have that, right, we're going to update, right, or we're going to re-implement, right, the DAO. The DAO currently is implemented using the database, this DB, which is basically a whole bunch of arrays, right? So we're not going to be using that anymore. So we're going to remove the database, right? We don't have that anymore. Instead, right, all these functions need to now use the model, right? So we're going to import the model. So import model from model. And now with the model, right, we're going to re-implement all this, right? So let's leave create user till the end. Right, so we're going to implement that a little later. How we do that? But for find all model for all user, what we're going to do is that we're going to use the model. The find function is just going to return, right, all the objects, right, all the documents in the users collection, right? In the find user by ID, we can use the model again, right? So let's comment that out. We do model dot find by ID, right? And this will retrieve that record by that primary key. Okay. And find by username, right, is going to use a model dot find one. So find one allows you to retrieve a single record filtered on a pattern, right? It's going to pattern match. Now this is equivalent to saying it's an object that has a field called username, and the value is also username, right? So this username, now there's a shorter syntax. You can just say username like that. It's a shorter, but it's going to pattern match, right, a record with the field or the property username is going to pattern match it with whatever we pass in as an argument. Now notice it's a find one. Now all these find by ID, find one, all these are wrappers around the find method. You only really need the find method. The find method can take an argument here of what is it that you're retrieving by, right? The pattern match that so all this pattern match here could be also written here. But the problem is that, well, not problem, but the inconvenience here is that the find method always returns an array, even if it's empty, right? It returns an array of no objects found, or if it finds a single document, then it's an array of one. So find by ID is just a wrapper around the find, but it knows that there's only one possible record that has that primary key, right? So it knows that it's just one, so it makes no sense to return an array of one. So find by ID, it's conveniently unwraps that array and just returns that one single object. Find one, similarly, right? The unlike find by ID compares the user ID specifically with the underscore ID, right? So it's just it's a convenience method that you don't have to put it in your curly brackets, underscore ID, colon, user ID, right? It does that internally. Find one allows you to pattern match any field, not just the primary key, but any field or combination of fields. But you know that because this is, say, unique, only one record could possibly match, right, that pattern. So you know it's only one. So this conveniently unwraps the array from the find, unwraps it and returns the first item in that array, right? It returns just a single object. Similarly here, right, in the find credentials, same thing. We know there's only one person that has that username and password combination, right? So again, we're using find one, and but we are pattern matching against two fields, your username and password. The combination of both have to match. Then we have now there's several ways of implementing updates. There's a find by ID and update. There's that version. There's another version, and either one is fine. There's update one, where you can provide an argument with the pattern match, right? That will find the document that matches that particular primary key that matches user ID, and then a command to replace, right, the documents, right, only the fields that match, right? So if you're only updating the first name, then it'll keep all the other fields untouched and only update that one field, right? So either one you could use on your update one or find by ID and update. This is somewhat of like a syntactic sugar around that, just a little more convenient. There's also delete user, also have several versions, right? There's model delete one, very similar to, and there's also find by ID and delete, right? And again, this is syntactic sugar around that. Yeah, so there we have it. So now we have replaced our implementation of the DAO so that now it's using the actual database as opposed to manipulating arrays. Okay. For the creating new user, right? We can use the model create. Model create inserts our new record. And what's happening here is that the record that is coming, the data that's coming from the user interface, right? This will have say the username and password, and we're going to copy over all those fields, but we're going to override, if there's any ID coming from the client, we're just going to throw it away. We're just going to override it and create it ourselves here on the server, right? Just to make sure that we are the ones responsible for creating this primary key that has to be unique. And then, we insert it. Create is the equivalent of inserting into a database, and we are returning the new instance that was inserted in the data in the actual database, right? And that's what we're returning from here. So yeah, now model create returns the object that was just inserted. Find ID obviously returns the user that we created, that was in the database. Model returns an array of users. Returns returns an array of users. This returns a single array of users. Update doesn't return. Notice that it's returning like this. See that? It's returning, but what it returns is not an object or record in the database. Instead, it returns a status, saying whether the update was successful, how many records were updated, right? So some meta information about what happened. And same thing with delete. It doesn't return an object instance. Makes no sense, right? Because the object has been removed from the database, doesn't exist anymore. So instead, like update user, it returns a status saying again whether it was successful or not, how many records were affected by the command. Now all this communication, right, going out to the model, going out to the server, all these are asynchronous communication to an outside process. So that means that we in the route that calls on the DAO, right? DAO now, it's not a synchronous process, is now an asynchronous process, right? Talking to the DAO is no longer now a synchronous call. All these functions need to be rewritten so that we know now that we are talking to a remote asynchronous process, right? That is running outside of, potentially outside of our CPU. So anywhere where you see access to the DAO, right, all these functions need to be converted into asynchronous functions. And all these, we need to tag them with the await, async await keywords. Okay, so sign in, sign up. Also, we have a DAO there. So there's a wait and a wait here. Let's see what else. We have update as well. We have async, async here. And that's all for now, right? But we have to remember any new updates, any new manipulation or interaction with the DAO needs to be async await. All right. All right. So we implemented the model, right? We rewrote the DAO, so it no longer uses the database. And we rewrote all our functions using the model instead of manipulating the array. We converted all our functions to be asynchronous await. And we probably also here, we don't need the database anymore, right? So also in the index, we have the database here, right? And we're not going to pass it down to the user route anymore because we're not using the local array anymore, right? We are going to be using the model. We did that, remove the database. Okay, so let's see, let's try it out. Let's try it out. Okay, so back in the client side here, right, we have our user interface running here, and we should be able to inspect and take a look at the network communication, right? And let's see if we can still log in using the same ADA 123 credentials, right? Let's see if it's in the database. Yeah, there it is, ADA 123. So let's go there and try to use that. So let's say ADA 123, sign in. And it seems that it's failed. Okay, might have the server. Is that running? Okay, the server crashed. Let's see. Can't find the schema imported from models. Okay, let's see. So let's look at the model here. Oh yeah, all these we need to have .js. And let's see in the route in the DAO model. Yes, okay. So let's see if it's booted up. Okay, booted up. Okay, let's try that again. Sign in. Okay, was successful. Went out to the server and it was able to retrieve the user. Perfect. Now the coordinates are still being retrieved from the array, whereas the user is being retrieved from the database. Okay, perfect. All right, so let's take a look at retrieving all documents. And what we mean by that is that, we're going to go through, implementing all the various operations that our particular application needs to use, from the, all the integrations with the database, all the operations of retrieving either a large collection of documents or an individual document or something that matches a specific pattern of username and password and so on, right? So we'll go one by one and implement all those, okay? So find all users, I think we implemented that in our DAO, right? And in our DAO, we have, yeah, there it is. So we have find all users, which is returning model.find, which by default, find always returns an array. And so what we might not have is the route, right, to retrieve that, right? So let's take a look at in the routes. I think we did implement the entry point somewhere here, right? There it is. So we have get and find all users. And yeah, we never implemented. Again, make sure that this is a async. And we're going to use the model, find all users await and respond with the users. Perfect. Okay. Now once we have that, we should be able to try it out, from the client. Right? We should be able to try out a new tab here and do a localhost 4000 API users, and there they are, right? This is the data from the database, right? And just to make sure that this is indeed from the database, right? We can make a quick modification to one of these records. So let's modify, say, Tony's email, right? Just to confirm that updates in the database are indeed being honored. So here's Tony, and let's say I'm going to modify this record, and instead of Tony, I'm going to say Anthony. Okay, and I'm going to say update. All right. So, going back to here, we should be able to refresh, and indeed, notice that we were able to modify the database, and indeed we are here retrieving the data from that database. Okay, perfect. So we created the route for retrieving all users. We just tested it. It is indeed retrieving all the users. We just need to integrate that on the client side, right? By introducing a new find all methods that goes out and retrieves all the users, right? So let's do that on the client side. Let's open up, here. Let's open up the client in the account, and let's find all users. So we'll do, export const find all users, async, there it is, okay? And once we have that, we're going to use that, right, to implement the people table, right? If you remember the people table that we implemented a couple of assignments ago, right, this was pulling from the local, quote unquote database, right, iterating over those users and displaying it in this people table. But we're going to make it a little bit more sophisticated, right? We want this table to be used for multiple places, right? Right now, it was only being used in the it was only being used when you went into a course, right? And if you go into the people, this is the people that are in the particular course, right? But say I log in as a system administrator, and I'm going to my account, we're going to make it so that that same people table is much more powerful, right? And as a system administrator, I don't just want to have read-only access to the people in the course. I want to be able to register new users, edit them, add, remove, do all sorts of CRUD operations across all the users across all courses. Okay, so let's rewrite this so it's more generic. Okay, so to do that, we're going to remove the the database, because again, we're going to be using the real database, right? And we're not going to filter the enrollments and so on, because all that's going to happen on the server side. Instead, right, we are going to take as arguments an array of users. So someone else is going to figure out the collection of users, right, and is going to pass them to me instead of me going to fetch them from the database. Somebody's going to do that for me and is going to pass me the users. Okay. And also, the people table is going to allow me to do some operations such as some CRUD operations such as creating new users, deleting users, updating users. So we might need to refetch the list of users. Say if I remove a user or update a user, I like to get a fresh copy of the users. So we're going to be pass here a callback function, fetch users to, so that we can we can tell our parent, the ones who's responsible for maintaining the users, so that we can let them know, hey, I did some changes. I think you should re-update the list of users. Okay. So yeah, so let's do that. So let's on the client side, let's move over to the table here. So let's see. So we have account, we have courses, and we have the people. Also, instead of being a page, right, we're going to convert it into being a component, right? Because it's going to be part of a page. A page is going to be using this table, right? So it's going to be a component. So let's rename this. So we'll rename this to table.tsx, and we're going to move it out of here into people, and we're going to get rid of the table here. So we'll delete the table folder. Okay. So in this table, we no longer are going to need the database. We're not going to use the use params either, so we don't need this, guys. Instead, and we're not going to filter either. We're not going to filter here. We're going to remove that. Someone is going to pass us the users. So there's going to be users like that, right? And we're going to iterate over that. Okay. Okay. So who's going to pass us that information? So we're going to create a new page, right? That is going to be used by a system administrator to be able to interact with those people, right? Be able to filter, be able to find, and so on, right? So it's going to be a brand new table page, right? Called the users page, and it's going to be accessible for by the whoever's logged in, typically a system administrator, right? So let's do that. Let's create this new page. So user page. So we'll do that in the account here. New user page. Let's copy that, and then we can take a look at it together. Let's discuss what this does. Okay, so here we have the user page, which is going to keep track of an array of users that is going to fetch the users on load, and then it's going to go out to the server using the client, right, that we just wrote 2 seconds ago, and is going to set the local array of users. This is not using reducers, right? It's only being used within this one page. It's not shared across anywhere outside of this page, so there's no need for a reducer. Okay. Also notice that it's loading the table, so the table is no longer a page, but instead it's a component that is being embedded in a larger page. Okay. All right. Yeah. So we have that. Also, we would like to be able to navigate to this brand new page, so we'll add a new link in the navigation of our account navigation, so that if we are admin users, we should be able to navigate there, right? So let's do that. Let's go to account navigation, and account navigation already, navigates to the profile, right? If we're logged in and whatnot. So we're going to add a new link here, right? If we are system administrator, we would like to have a new link under there, right? Under here, here's nav, a new nav item that is going to take a look at the current user, looking at the role. If it is admin, then it's going to add a new link here, right? So that will allow us to navigate to users, right? So let's take a look at that. So if I refresh this and I log in as Ada, I think she's an admin. So let's do Ada 123 sign in. If I go back to my account, notice that I have a new users link, right? Because Ada is an admin. If I click on users, there it is. So this is our brand new people table that's going out to the server, retrieving this, right? All these users from the database. Right? If I refresh, and we can see in the network the query that goes out to users. There it is, including our Tony Stark, whose email indeed has been modified. So this is indeed data that comes out from the database, and we are displaying it here in our new user table. Okay. All right. All right. So this is going to give us a chance to again practice the most common operations. We already saw one of them being retrieving all the documents, right? And perhaps to populate, a long list or table or, grid. Um, Here's another one that's also very, very, very common, that we want to retrieve, right, a subset of documents by some predicates. So let's come up with a couple predicates. For instance, one common um, use case is that we want to retrieve a subset of the documents based on some criteria. In our case, we have users. Users can be categorized by their role, right? And so I want to be able to by their role. So let's create in the DAO a new finder that can find users by their role. Okay. So here on the server, right, in the DAO, we can create a find user by their role. So let's create that. So let's see, const find users by role. Here's role. There it is, right? So now notice that there could be more than one. So dot find makes sense, right? That it returns an array. There could be many people that have the same role, right? So find is just perfect, right? We also have to expose this in our API. And then in our route, now because uh, filtering by a predicate, it's not we're not filtering by primary key. For instance, this is what is filtering by primary key. We're following RESTful API conventions that we encode the primary key as part of the path. But if we are filtering by something other than a unique identifier like the primary key, right, the convention says don't encode that in the path. Instead, encode it in the query, meaning that it would have to, the path would have to look something like this, /API/users. And then after that, you would have the query, right? Query say, role equal admin or role equal faculty or something like that. So that means that it would by necessity, pattern match against this path, meaning that it will call this function, find all users. So find all users now has to be a little more sophisticated, right? It only should retrieve all the users if there's no filter, right? If we're not filtering by anything else like role or something like that. But if we are filtering by role, then it should return a subset of the roles, right? Not all the users. Make sense? So meaning that here we need to filter and say, well, first check to see if there's a role in the query, right? So if there's a role, then we're going to use our brand new find users by role, and we should just respond with that subset of users, right? And immediately return. We're not going to continue because we're done. We just responded with that subset of roles. Okay. So so yeah, so we have the on the server, right? We're retrieving those users. Now on the client, right? We need to again retrieve that data, from the user interface and encode the role as part of the same URL we use to retrieve all the users, but right, we encode the role at the end, right, so that right when it gets to the server, we can retrieve that query at the end of the URL, right, and then invoke this part of the function, right, and return and get the subset of users. So in the client, right, let's implement our find users by role. Right, so on the client, we can say export const find users by role, and where we are going to encode the role at the end of the query string like this, right? So that means that now from the front end, we would need maybe to some kind of user interface where we can select the role, perhaps maybe a drop down, right, with like a select statement, a select tag that has all the options by which we want to filter, that have a student, TA, faculty, and whatnot, right? And so what we could do is that we want to, as we change, the role, right? We're going to call a local function, filter users by role. There it is, right? That is going to, set a local state variable, right? That we're modifying as we change the dropdown. And then if it's a role is selected, it's going to go out to our server, right, to retrieve the subset of users by their role, right, and then set the local array of users, which is then passed down to the people table, and it should re-render. Okay. All right. So let's do that. Let me just copy this over. So let's copy this over in the users. So let's see, in the users page, right, we'll have the array, the state variable. Oops, no, I guess I copied. Did it copy? Copy. There it is. And we'll have the drop down below where we can select the role. And we'll put it right below the users. That. Okay. So there it is. So we have a new all roles. Okay. That we can try it out. We can see the inspect. We can see the network going out, and we see how it's going to encode the query. Right. So let's see. We can filter by students or by faculty. Okay, there it is. Only Tony and Frodo are faculty. And notice how the URL went out, right? And it's encoding, right, the role at the end of the query. See that? Which is targeting that specific part of, find all users, right? It's only returning a subset of those users, right? And so the faculty, assistants, administrators, we have Ada, right? And we have all roles returns all of them. Okay. All right, excellent. So another common predicate is that it's a free form piece of text, right, that we want to search by and pattern match against a particular set of fields or combination of fields, right? And for that, it's regular expressions are very useful. So here, for instance, we would like to be able to search by or filter by first name and last name, so that if you start typing an input field, right, it'll pattern match whatever you're typing against certain fields that are ASCII, such as first and last name, right? So for that, regular expressions are perfect for that. Right? So we can on the server, we can implement find user by partial name, and we'll export that. And the way we're doing it is that we're creating a regular expression, right, where we use the partial name, and that regular expression, we're going to compare it against first name, right, and last name. We're going to say, okay, well, find me all the records who here we have an OR, a logical OR, that is going to check the two predicates, right, in the array. The array has one predicate here, another predicate here. So if any of the two are true, then it's going to make it into the final array of records that match. And so we're going to compare the first name against the regular expression and the last name against the regular expression for each record, right? If it matches, right, that whole record will make it into the response. Okay. So then in the route, right, this is the same thing, right? That because we are filtering by non-primary key, right, such as name, first name, last name, whatnot, right? Then because of that, we need to filter by the query again, like we did for the role. So if we're not filtering by role, now we have to check to see whether we're filtering by name, right? And so if there's no role, but well, let's see if there's a name, right? If there is a name in the query, then I want to parse it out and use my new find users by partial name, which will compare the regular expression against first and last name and return the subset of users that match. Okay. Then in the user interface, right, we need to encode the first name, like we did the role, right, at the end of the URL, right. In the client, we'll encode the name in the end of the URL, just like we did with the role, right. We're going to pass in the name as an argument. We might need, I don't, well, maybe we do need credentials. So, and so now what we need is also now an input field where we can type, right, the name that we want to filter. So let's create a state variable that can hold the name by which we're filtering, and then the query that retrieves the name as we type. Right, is going to send this name, this partial name, off to the server, which is going to cause the query to rerun. Right. So in the user, right, let's have a new name input field, state variable that we can type into, and as we type, we're gonna cause the server, right, we're gonna send our partial name off to the server for every keystroke as we type, right, and do the filter as we go. Okay, so we'll have a new input field that, right, that we can type that partial name. So we'll put it right next to our select drop down here, and there it is, search people. And so and notice that every time we type, as we type, right, the new value, right, is going to be sent off to the server and filter out, right, the users that have a partial match on that name. So let's try it out. So here we have search people. We can say A. So now it's going to look for, the query went out A, and now we already have a smaller set of users, a R, so Stark or a SAR, right, or Argon. And so we're getting a subset of the user. Notice that every query, notice this was A, this one with AR, and their previews see that this one returned only 2, and this one returned 8. Okay, and Stark. Okay, retrieves only that Tony Stark. Okay. All right. So another very common use case, right, when interacting with a collection of objects, a collection of records, is to retrieve one record by its primary key. And so I believe we already have this in the DAO, right, where we are filtering our records by its ID, right? Let's make sure we do. So in the DAO, I believe we have, find user by ID. There it is, right? So we're using the syntactic sugar function, find by ID, which is basically a find, right, that filters by its primary key underscore ID, and then it unwraps the single object that comes back in that array. So it finds that one record. And so in the route, right, we are going to now use this new function, which I believe we are might have already implemented it. Let's see, in the route, we have here there is a find user by ID. Yeah, it's not implemented, so it'll make sure that there's async, and we retrieve the ID from params, yes, which is, yeah, it's encoded in there as user ID, perfect. And we're gonna use the new DAO to retrieve that user by its primary key and, yeah, respond with that user, perfect, excellent. Okay. Once we have that, we can now write on the client side the find user by ID, which is going to encode, again, using RESTful Web API's convention, encoded not in the query string, but as part of the path. Okay. Uh, so yeah, so on the client side, right, we can write the find user by ID. I believe we don't have it. Perfect. Okay, so let's do export const find user by ID. We have the user ID, and it's going to encode it at the end with at the end of the path. Perfect. Okay. And what we're going to do is with this query, right, we're going to populate a new details dialog. It's going to be a dialog that kind of like pops out of the sidebar. It's going to be a sidebar that kind of like hovers on top of the page that, we're going to give it the ID of the user that we want to display. And we're going to give it a function that is going to allow us to close it, right? So that we can dismiss the dialog, right? And so this is going to be driven by the new users folder, the new users page, right? That if we click on the name, we're going to have a little pop-up here, dialog, right? That will display the details about that one user. We'll pass in the ID of the user's login ID. We'll pass it in, right? And it'll fetch this one user from the server and display and populate that dialog, right? And then we'll dismiss it, and we'll be adding more capabilities to this dialog of being able to edit it, right? Delete it and whatnot. Okay. So yeah, so let's implement this. So let's create this new sidebar dialog, and we'll put it in details. It'll be a new component that will hover on top of our table. So let's see, right next to our table, here we'll create a new details dialog. And it's going to be implemented as follows. And let's copy the rest here. Okay, here we go. So let's go over this real quick. So yeah, so it's going to be a new component, takes as argument the ID of the user that I want to display the details for, and an onClose so that we can dismiss the dialog. We're going to have a local state variable that's going to capture the user, and if the UID comes in, we're going to, if there's a UID, right, we're going to call a fetch function that is going to go out to the server, right? There's our query that's going to do the get, it's going to pass in the ID in there, and this is going to encode it at the end of our get request. Okay? And when it comes back, we're going to copy the user from the server into a local state variable, and we'll populate the first name, right, the role, the login ID, the section, so all the details for that one user. Okay, all right. And yeah, we'll add some more interesting capabilities as we go. Okay, all right. So we have that, and so what we'll do is that we're going to um, include the people details so that in the table. So the people table is now going to have this detail that is only going to display, right, if we're going to have a Boolean flag, whether the dialog is displaying or not, that we can toggle, right? We'll toggle it on when we first fetch right? The when we have the user ID, we're going to turn on and off, and then when we dismiss it, right, it'll show the details, to off. Right? If it's on close, it'll set it to off. Right? And we'll pass in the fetch users argument, right, attribute, so that if the people details does any modifications to that one user, maybe changes something, changes the email, or it's deleted or something, right? Then, right, we'll notify the parent user table, the user page, right, to refresh the screen and refetch the users. Okay. All right. So yeah. So let's bring in the people table into our details in the table. And let's see. We have the table right here. So we'll import the details dialog. We'll have here a flag to display or not the um, the um, the dialog. Okay. What else? We'll need the fetch. We're gonna pass it in, so that's gonna be a new argument that we're passing. So this is a function. So fetch is a function. Yeah, and that function, we're going to pass it down to the field, to the details, so that on close we'll know to refresh the content, right, of the table. Right? So yeah, so if the show details is true, then we're going to display the dialog, and so we can toggle it on and off, right? So we can hide or show the dialog, right? So we're going to have it right here. And fetch users is okay. Okay, so this is not optional. You have to pass in users. And we're going to call fetch users if something happens, right? If you modify something in the user. Okay. Let's see. Let's say, okay. What else? Yeah. So now what we'll do is that we're going to have the first and last name, or it could be the whole row, right? That you click on anywhere in the row, you can do that. Yeah, let's do that. The whole row can be clicked, right? So we'll do an on click, right? So that if you click anywhere in the row, so here's the row. Let's see, here's the row. So if you click on the row like that, what we'll do is that we'll set show details to true, and we'll copy the ID of the user, right, of that particular row, right, into the state variable so that we can pass around to the details, and the details can then know which ID to enter. Okay. Now, we do have here expecting fetch user to be passed into the table, but that's in the users page. We have the fetch right here, right? So we need to pass that down to the people table. It's expecting that as a reference. Okay, perfect. All right. All right, so let's try it out. So now if we click on any one of these, notice that, right, the user is being fetched, right, Black Widow here, right, and it's being displayed here on the side displays. We can close it and refetches the user. In this case, we didn't need to refetch the user. So we could be smarter about this. Whether something changed or not. If nothing changed, there's no need to fetch the user. But here we're blindly just fetching all the users. So yeah, so we can Bruce Banner, there it is, or Frodo Baggins. So we can click on any one of these, right? And the dialog here fetches the user, the unique user, right? And then repopulates the dialog. Okay. Or we close and then it just dismisses. Awesome. All right. How about deleting a document? Right. That's another very common use case. So yeah. So the DAO, I believe we do have a delete user on the server. In the DAO, we have delete one. Right there it is. Delete one, and it's exported. And now on the route, do we have delete? There's delete user. Right, that's not actually implemented. So let's implement it using our model. So async, And here we get the ID from the path, right? And we're going to, the delete user actually going to return a status. So we're going to say const status, and we're going to respond not with the status 200, but we're going to send back the status. This includes meta information such as whether it's successful or not, how many records were actually removed. So that information is great to have on the client side, right? So that you can give more informed statuses if it fails, right? Something goes wrong, right? We can use what's in the status to let the user know what's going on. And so once we have that, right, on the route as well, now on the client side, right, again following the the stateful RESTful web APIs, we are using delete, right, and we are encoding the ID in as part of the path, right? So let's copy that and put that in the client. So here's delete. And what we'll do is that we're going to add a new delete button, right, in the details that is going to call that server action, right? So the details, right? We'll create an event handler that we can call here. There it is. And that we're going to invoke from a new delete button, right? So we're going to add two buttons at the bottom. One that calls the delete, right, with the user ID, right? And then the other one just closes is a cancel button that just basically just closes the dialog, right? So yeah, so let's that will be displayed at the bottom of the details sidebar. So let's see, let's add this at the bottom. So one of them calls delete user. Delete user first sends out a request to delete. Right, with the status, we're ignoring the status coming from from the server. Certainly, we would want to take a look at that, and and if it failed, let the user know, right? And then here on close, right? So yeah, so let's see. Let's click on any one of these. So let's say here's Bruce Banner, and now we have our new cancel and delete. If we just cancel, we just go remove, doesn't remove anything. But if we do Bruce Banner and we delete, boom, it's gone. See that? And it was removed by sending a delete. Here's our delete. And the response is the status saying that it was acknowledged, it was successful, and how many records were removed. If it weren't removed, this would have said that it failed, right? And and why it failed and whatnot, right? And then because we made a change in the database and there's one item missing, it makes sense to go fetch the users. Or we might be more, we could be a little smarter than this, right? Instead of refetching it, we could just edit the local array of users, right? Just filter out that one particular user by the ID. We could be, maybe a little smarter about that, right? Instead of refetching it, but it's just another way of doing it. All right. Yeah, so we have a delete and cancel. And how about updating? So updating, again, another common use case, right? That we want to maybe replace particular field or property in a document. And you give me the ID of the record that you want to modify, and then all the modifications in here would be either all the fields or maybe just a subset of the fields. Maybe you just want to change only the password. So for that, there's a $set command in Mongo, right, that allows you to do kind of like a merge, right? And so that only the fields that are mentioned or in this object, right, will be modified. All the other fields will be left alone, right? So it doesn't if you have a subset, it's not like it replaces the object with only the fields that are in here. It doesn't merge, right? And only those fields that change are the ones who are going to be modified, right? So So I believe we have that in the DAO, the update. Yeah, so ID, yep, it's okay. So for the route, I don't believe yeah, it's a new implementation, so I'm going to copy that implementation. Yes, definitely it's a sync, it's a wait, but also I want to consider the fact that the previous implementation was assuming that I was always modifying my own user, right? So I logged in, and through the profile I would modify my record, my information. But because here you're a system administrator, you would be modifying not only just you, but you could be modifying someone else's, right? So in that case, right, if it's you, then it makes sense to update also the current user, right? Because you are logged in, you want to make sure that the current user in the session is also updated, right? But if you're updating someone else, then that someone else is not the person who's logged in. It's you who's logged in. So the session current user in the session should not be modified. So here's a modified version of the update user, just checking to see that yes, I'm updating in the database, but the current user, I want to make sure if the ID you're giving me is the one in the session, then yes, I want to do the modifications. Otherwise, I don't want to touch it. Okay. Yeah. So let's see. In the client, I think we already have the update user. Let's check. So in the client, let's see, update user. Yeah, so we already have update user implemented. So what we're doing in the user interface, we're going to do something, something interesting. What we're going to do is that we're going to have an input field, right? That's going to allow us to modify the first name and last name only, right? I mean, you can extend this so that you can modify any field, but I'm going to focus on just updating the first name and last name. So there'll be one single input field that is going to allow me to modify both the first and last name. And once you save it, we're going to take the first and last name. It's going to just be a single string, right? But we know it's going to be separated by at least a space in between the first and last name. We're going to split it into two, first and last, and then we're going to create the user with the updates, right? And we're going to be overriding the first and last name. We're going to send it over to the server to be updated. And then, whatever updates come back, right, we update the local user object, right, and refresh the fields, right, in the dialog, right. And once we save, we close the dialog, we dismiss it, right, and this will refetch and re-show, right, any updates that we have done to that particular user. Okay. So yeah, so let's take a look at the details, and let's import a couple of icons. And this is imported twice. And here's our field that is going to allow us to edit the first and last. So let's add it here. There it is. And then what we'll do is that our current username and first name is just two fields that are being displayed. We're going to replace that so that if you click on it, if you click on the name, the first and last name, right, we're going to have an on click, which is going to set a local state variable to true, meaning we are editing this particular user, and we're going to keep track of that here, right? If there's a flag, are we editing or not editing, right? If we're editing, right, we're not going to display, we're going to stop, we're going to hide the original first name and last name, right? Instead, we're going to display in its in its place, we're going to display an input field. See that? We're going to display an input field that is going to have a default value of the current first and last name. And as we type, right, we're going to set, the local name, right? We're going to break it out first and last. But then if you press enter, right, we're going to click on save user. We press the enter key. Also, we're going to display, if we're editing, we're going to display a little checkbox, right? So that, if you, not checkbox, a check mark. So if you click on that check mark, right, you also can call save user by clicking the check mark or by pressing enter. Also, if you're not editing, we're going to show a pencil so that if you click on that pencil, we enter the editing. So you can enter editing either clicking on the first and last or clicking on the pencil, right? So let's do that. So this is going to replace, right, our current first and last. Right, so if we go to first and last, right here, we're going to replace that with this, right? We'll have to import a few things here. All right. Oops, I think we did this twice. All right. Yeah, so let's see. Let's fetch. Here's Tony. There, so here's Tony that we fetched from the server. There it is, right? And again, you can click either the pencil, right? Oops, I didn't do any modification. Wait, so this is Antonio. Enter. There it is, Antonio Stark. And so it went out. There's the update, the put. The payload is that we are changing the first name to Antonio and Stark. And we can check to see in the database to make sure that that change actually went through. Here's Tony. Let's refresh. And indeed, yeah, it was changed to Antonio. Okay, so yes, we are updating the user. We're refetching it, right, and redisplaying the users, right, with all the updates. Okay. Right. How about creating new documents? Right. Again, that's one of the common operations. All right. So I think we have this DAO create user. Let's see, the DAO we have yeah, create user. I think it's the same implementation, right? Yeah. And now in the route, right? We are going to call the DAO create user with whatever you passes from the user interface. And once it's inserted, I will send you back this one user that you can, add to your array of users, right? So in the route, create user, I think it's here, there it is. We're going to paste that in there. And then on the client side, right, we're going to post this new user, again, following the RESTful Web API convention, pass in the user in the body, right, to a post to create the new content. So here in the client, let's do a create here. There it is. And in the user page, what we'll do is that we'll have a new button that creates just bogus users, right, with some default names like new user. You can then go in and edit it, right, by clicking it and putting the correct value. So here's a create user that's going to use a new create user to post this information out to the server, creating a bogus user with a new user, last name user, blah blah blah, with some unique identifier which you can edit it later. Okay. And just appending it to a local array, right? So yeah, so let's copy that and go to the users page, right? And having here's the create a new user, and we'll add a new button right at the top, right? So that when you click it, right, we'll have a plus sign that if you click it, then it'll call this new create user, right? So we'll need to import the a few things here. There it is. So now we have a new user, right? And so if we click on it, notice that down below we don't have a new user. So if you click on new user, it's posted and we're adding at the bottom. See that? And so here's our post, right, with the bogus user information that comes back with the primary key generated on the server in the database, right? And then we're just adding it here. We can always edit it. We can click on new user and we can edit it here, right? And this can be John Doe. Okay, we can add a few more. Oops, wait, did we? Huh? John Doe, wait, create. Uh-oh, the server crashed. Let's see what's going on here. Mongoose cannot specify an ID or model that does not allow overwriting ID. Overwriting ID. Oh, all right, debug that. But yeah, you could create it and then edit it. All right.